So welcome back, Level 3 physicists, continuing on with our non-linear standard, looking at errors, and today we're looking at how errors build up, or errors are propagations. Okay, before we do that, let's just recount our experiences with significant figures. We'll revise them. So there's 4 rules. The first one is that zeros in the middle of the number are going to be significant. Zeros at the beginning of a number are not significant. Zeros at the end of a number and after the decimal point are significant. And finally, zeros at the end of the number and before an implied decimal point may or may not be significant depending on the context of the experiment. So in terms of rules for multiplying and dividing significant figures, the answer cannot have more significant figures than the original numbers. It can't be more accurate than the original numbers that you started with. So in the example we have here, 278 is 3 significant figures, 11.70 is 4 significant figures. So therefore the answer has to be in 3 significant figures because the distance in miles is 3 significant figures, so 23.8 miles to the gallon. The rules for adding and subtracting significant figures, your answer should only have the same number of unit placings as the most imprecise number. So the examples there are 0.011 has 3 unit placings, whereas 0.01 has 1 unit placing. Therefore, the answer has to be rounded to 2 unit placings, and 0.02. And then 90,000 plus 900 gives an answer of 90,900, but remember that there's only 1 unit placing for 90,000, so it has to go with that, so it's 90,000. So in terms of uncertainty and error propagation, we've got absolute uncertainty, which we looked at in the last lesson, which is the plus or minus value in a reading or a value. The relative uncertainty, which we'll look at next, which is a plus or minus value in the reading divided by the reading. And the absolute error is the measured value less the accepted value. And finally, the percentage error is the measured value less the accepted value, all divided by the accepted value, which is going to be the final part of your internal assessment, because you have to compare your value that you can't calculate experimentally from the gradient to the actual value. So in terms of relative uncertainty, it basically compares the size of the absolute error compared to the actual reading you've got, and the equation is that the relative uncertainty in x will be plus or minus the absolute uncertainty in that value x divided by that particular value of x. That becomes more important when we look at error propagation when you're dividing and multiplying. Okay, so these are the rules. So for addition and subtraction, you add absolute uncertainties together. For division and multiplication, you add the relative uncertainties together, hence we need to calculate the relative uncertainties. And the final uncertainty is a single significant figure, and the final value is rounded off to a similar number of places as the final uncertainty. So for example, if you're measuring the resistance of a circuit, or a component at least in a circuit, if you get an answer of say 15.07 plus or minus 0.015 ohms, then you round that to 15.1 plus or minus 0.2 ohms, okay, because you've got the 1 decimal place, and you've also got the 1 significant figure of 0.2 ohms. So also, because you are going to be calculating the uncertainty in powers, because you're going to be doing and investigating non-linear relationships, you have to work out how to calculate the uncertainty with powers. So the error in a x to the power n kind of relationship is going to be equal to x to the power of n, being x being the value, times the absolute value of n, that power, multiplied by the absolute uncertainty of that value of x, and divided by the value for x. And finally, in terms of your internal, you have to compare your calculated value with the expected value, and to do that you have to use percentage error. So to do that, it's basically taking your measured value from your gradient, subtracting it from the accepted value from literature, and divided by the accepted value from literature times 100, which gives you a percentage number, and usually between 5 and 10% is acceptable.